last time. And what do we know about dilations? They're not congruent and they produce what? Similar shapes. Okay? If our scale factor is in between 0 and 1, what happens to our shape? It's reduced, so a reduction occurs. Okay? If our scale factor is k, which is greater than 1, what happens? An enlargement. Okay? When you have similar figures, your original shape is called what? Pre-image, and your new shape is called image. When we're talking about scale factor, how do you figure out what the ratio is? New over old. So remember snow. Scale factor equals new over old. Okay, now I have two similar shapes. What do I know about those similar shapes? Corresponding angles are congruent, and Miranda? Corresponding sides are proportional. Okay, so corresponding angles are congruent, corresponding sides are proportional. Okay, so now we're going to talk about other triangle theorems that are going to allow us to prove that triangles are similar. Okay, so first thing, when polygons are similar, two criteria must be met. And what are those? What happens when polygons are similar? What two criteria are met? We just talked about it. Very good. Corresponding angles are congruent and corresponding sides are proportional. However, you're going to run into scenarios where you don't have every single angle measure. Maybe you only have one. You don't have all the side lengths. Maybe you only have two, or maybe you have one, or maybe you have all three and no angles. So we're going to talk about different ways to prove triangles are similar. So the first one is AA similarity, and that stands for angle. So angle similarity theorem says that if two angles of one triangle are congruent to two angles of another triangle, then the triangles are what? Similar. Okay, and it marks it in your figure for you. So this angle is congruent to this angle, and this angle is congruent to this angle. So that forms two sets of congruent angles, which allows you to use angle similarity. Why do you think you don't have to have AAA? Because if you subtract it from 180, if these two are congruent, then this one has to be congruent. So it's kind of like implied. Okay, so if you put AAA, it's not necessarily wrong, but you just need two sets of congruent angles because that third one has to be congruent because there's only three and the sum has to be 180. Okay, so looking at our examples, can these triangles be proven similar by AA? If so, write a similarity statement. Okay, right off the bat, what two angles do we know are congruent? C and B. And what do we call those two? Right angles. So we know C and B are equal or congruent because they're right angles. What other angle do we know is congruent? Okay, not just E, but CEA and BED. When there's two angles stemming from a vertex, you cannot just use one point to name the angle. You've got to use all three to name the angle, not just one if there's more than one angle coming from it. Okay, so why is CEA congruent to BED? Because of what? Some old vocab. I think I hear somebody whispering. What did you say, Fernanda? Vertical angles. Remember, vertical angles are what? Congruent. Vertical angles are always congruent. So all your old vocab is coming back along with proof. Imagine that. Vertical angles are always congruent. Okay, so we now have two pairs of angles congruent. Therefore, we can say that the two triangles are similar by AA. So let's go ahead and circle yes. Okay, we've gotten into the habit of just throwing our 3 points and naming our triangle in no specific order. And it's worked for us up until this point. Now order does matter because the way that you write it is how the angles correspond to one another. Okay, so if I write this first triangle, let's say ACE, then my second triangle has to be written in a specific order. What angle corresponds with A? D. What angle corresponds with C? B, and E goes with E, obviously. Okay, so now order does matter. You have to make sure that the angles are corresponding with one another. Okay. Questions on that? Okay, so now that these two angles are these two triangles are similar, ACs over DB would equal BE over what? AC over BD would equal BE over what? Oh, not BE, sorry. AE over what? DE. So notice how now you can start creating your proportions because you know that the triangles are similar. Okay, so that would be like an extension. Okay, so now that you know they're similar, we could say things about the sides being proportional. Okay, letter B. Okay, somebody tell me one set of congruent angles. Noting that these two sides are parallel. JH what? JHK and okay, why is that? Because of what? Vertical angles. So in a proof, we're kind of doing a proof as we're going. Do y'all see that? So like your given would be line JK is parallel to GF. Okay, now we're saying that JHK is congruent to GHF, and then in our reason column you would have vertical angles definition or whatever. Okay, what's another pair of congruent angles? If I turn it this way, will it help? Since these are parallel. What other angles are congruent? JH what? KJH and what? And HFG, why? Okay, not opposite, close. What is it called? Alternate interior angles. So remember when you have your parallel lines cut by the transversal, opposite of the transversal, same side or inside of the parallel lines, you have alternate interior angles. Remember that? And it forms that little Z. Okay, same thing would go for JKH and HGF. Okay, these are opposite interior angles. It's just the backwards Z. Okay, so now everything's coming full circle. You've got to be able to identify these sorts of things. Okay, so we have our two pairs of congruent angles. Okay, so if I were to label this JKH, what angle corresponds with J? F, G, H. Okay, so the way that you tell corresponding is the ones that are congruent. Okay, so J is congruent to F, so that's why it's written in that order. Okay, so remember, I'll write it up here again. Angle KJH is congruent to HFG, alternate interior angles. Questions on that? Okay, so that is a similarity theorem. Okay, example 2 says you can use AA similarity to find missing measurements in a triangle. So given this figure, what is one set of congruent... Whoa. Interesting. I just have like this sea of ink. I don't know where it came from. Okay, anyways. Given AB is parallel to CD... Okay, AB is equal to 4, AE is equal to 3x plus 1, CD is equal to 8, and ED is equal to x plus 12. Find AE and DE. Okay, first, before we get started, before you ever start solving, you want to make sure that your triangles are, in fact, similar. Okay, although it tells us to use AA similarity, let's make sure that AA works for this two sets of triangles. Okay, so what angles are congruent? Okay, what else is congruent? What other angles are congruent? BAE and what? CDE, because of alternate interior angles. Okay, so now we do know they're similar. Okay, AA theorem. Okay, so what do we know about their side length? Side lengths of similar figures are always proportional. So how could I set up this proportion? X plus 12 over 3x plus 1 is equal to 8 over 4. You could have had 4 over 8 equals 3x plus 1 over x plus 12. You could have solved it a bunch of different ways. But this is one way. And then how are we going to solve for x? Cross multiply and divide. So I have 4 times x plus 12 equals 8 times 3x plus 1. 4x plus 48 equals 24x plus 8. Subtract 4x. 48 equals 20x plus 8. Subtract 8. What does x equal? 2. Okay, but what does our question ask us for? AE and DE, so what is the length of AE? 7. What is the length of DE? 2. Questions on how to apply angle similarity. You always include units when you're talking about side lengths. I don't know necessarily if I'd count it wrong, but just kind of get into a habit. Okay, next one is SAS similarity. What do you think that stands for?
Side angle side.
Side angle side. Okay, so in two triangles, if a pair of corresponding angles is what? Angles need to be what? Congruent. And the sides including the angle are proportional. then the triangles are similar. Okay, what it means to include the angle is that if I were to sandwich the two sides that I'm given, I would pop the angle in between. Okay, so it can't be like this side and this side, because if I sandwich these two sides, I'm popping this angle. Okay, so whatever two sides collapse on that angle, that is the only time you can use side angle side. It can't be on an opposing side that doesn't have an angle in between it. Okay, so it's always always the sides that include your angle. Does that make sense? Okay, so can the two triangles be proven similar by SAS? If so, write a similarity statement. So these similarity statements only apply if the triangles are similar. So if they're not similar, you would not have a similarity statement. Okay, so right now we have 120 degrees. Okay, that's a congruent angle in both figures, so you know that you at least have an A. Now we have to figure out if our two sides are proportional. Okay, so what proportion could we set up? 4 over 6 equals 6 over 9. Okay, yes. Oh, sorry. Okay, so 4 over 6 equals 6 over 9. You can either reduce your fraction and see if it reduces to the same scale factor, or just cross multiply and see if you get the same number. So these either both reduce to 2/3, or when you cross multiply you get 36 equals 36. So you know that they are proportional. Does that make sense? Okay, so we know that both of the sides are proportional, so we can say that the triangles are similar. Okay, if I name this MLN, what do I have to name my other triangle? PQR. Questions on SAS? I don't know where all this red is coming from. It's like all over my paper. I mean, I know I'm writing in red, but okay. SSS, what do you think that stands for? Side, side, side. Okay, this time, if all three pairs of corresponding sides of two triangles are proportional, then the two triangles are similar. Okay, so if all three sides are proportional, then they must be similar. Okay, so the thing about testing SSS is you can't just set up one proportion. You've got to set up a minimum of 2 so that you can see that all three sides have the same ratio. Okay, so somebody give me one proportion that I could set up. 3 over 9 is equal to 4 over... Oh. Okay, I'll go this way. 5 over 15. Okay, when I cross multiply 15 times 3, 45. 9 times 5, 45. So we know that one's good. Okay, and we need to test one other side, which is 4 over 12. 9 times 4, 36. 12 times 3, 36, so we're good. Okay, and then if you want to line them all up, you have 5 over 15 equals 3 over 9, which equals 4 over 12, and all of those simplify to what? 1/3. So they are similar. Okay, you can do it either way. Like I said, you can reduce your fractions or see when you multiply if you get a true statement. Okay, if I say STU, in what would it be similar to? XWZ. Oh, V. Questions on SSS? Okay, those are our 3 theorems. So you have AA, you have SAS, and you have SSS. I can guarantee you on a multiple choice or even in a proof, somebody will try to tell me that this is a theorem. If you find yourself writing that, stop cussing at me and know that you are wrong. Okay, that is not a theorem. Angle side side is not a theorem. Okay, they might be more, nice and say SSA. Okay, but that is not a theorem. Okay, they're not tricking anybody. Okay, it is not a theorem. Okay, so angle, angle, side, and SSS. Got it? Okay. So don't cuss at me. Okay, examples. Here we go. Now we're going to put it all together. Are the 2 triangles similar? If so, state how and write a similarity statement. Okay, when you have triangles that are overlapping, okay, I would encourage drawing your 2 triangles separate. Okay, so I have triangle XWV, and this is 80 degrees. And I have triangle XZY. Which is 80 degrees. Okay, so what do I know so far? They have one angle not in common, but one angle is congruent in both, and that is W and Z. Do we know anything else? They share the same angle, which is X, so X has to be equal to X, so those have to be congruent, right? So we might not know what the actual degree is, but because they're being overlapped and they're sharing that angle, you know that they are congruent. So therefore, what do we have? Angle, angle, similarity theorem. So it's yes by angle, this little, I think it's called a tilde or something like that. That thing is called similarity. And then you can just say THM for theorem. So angle, angle, similarity, theorem. Okay, if I say triangle XWV, that would be similar to what? XZY. Right on. Okay, number 6, we have to redraw as well. You have LKM. You know that LK is 6 and LM is 10. Then you have a bigger triangle, which is LJN. What is the length of LJ? 9. And LN? 15. Okay? What do we know is congruent in both? LY. Because it's being shared. Okay? A lot of people forget that and they think that if they're not similar, they don't have enough information to make a claim. Okay? Make sure you account for those shared angles. Okay? So now we have an angle. So we're definitely not using side, side, side. We're either using angle, angle, or side, angle, side. Which one do you think we're trying to use? Side, angle, side. So now let's see if it's true. So what proportion am I going to set up? 6 over 9 is equal to 10 over 15. Okay, if I cross multiply, I'm going to get 90 on both. But if I reduce, what do I get? 2/3. So 2/3 equals 2/3. So we are good. We have the same scale factor on each side. So therefore, they are similar by side, angle, side. Okay, if I label the first triangle LKM, what's the second? LJN. Okay. So when you're lining up your triangles, you want to make sure that you look at their corresponding sides. Like for example, right here, there's no clear indicator of like, ooh, which vertex goes with which, or which angle corresponds with which. Okay, but you know the sides that correspond with each other, because you're not going to put the big side with the little side. Okay, you want to still line up your triangle so that the small, say if you want to put the small side over here, that the small side of the other triangle is over here, and then maybe medium and long, or however you do it. Okay, so, for example, I have small, medium, long, so when I draw my other triangle to face in the same direction, that looks nothing like it, but that's fine. Okay, my long side is what? 12. My medium side is 10, and my small side is 6. So now that I have my sides, now put your points in order. Okay, so I know that H is between 6 and 10, so that one's going up here. Okay, F is between 6 and 12, so that one's over here. And then in between 10 and 12 is E. Okay, so that's how you can figure out which angle corresponds with which. Because obviously my 10 can't go on this side. Okay, because this is where my smallest side goes. Okay, do we have any angles that are congruent? No, so probably not going to be using AA or SAS. So what do you think we're trying to prove? Side, side, side. Okay, so somebody give me one proportion. 3 over 6 equals 5 over 10. Both those reduced to 1/2. Okay, what about the last ratio, which is 6 over 12? 1/2. So all of them reduced to 1/2, which means what? Yes, by side, side, side. And DEG is similar to HFE. Okay, so notice that even though they both have E, they don't go in the same spot. Okay, because it's not a shared angle. Okay, example 8 is solving for X and Y. So what's the first thing that you should probably do? Pull out your triangles. So you have a small guy and a big guy. Okay, you have A, E, C, and B, D, C. Okay, AE is 8, BC is 3, DC is 4, EC is 7. How would you label AC? 3 plus X or 3X? 3 plus X. Okay, because it's the AB plus BC equals AC. Okay. Alright. Oh, and then I have Y. Sorry. Okay, how do you suppose I would go about solving for either variable? You don't want to solve for both of them at the same time. You want to solve for one at a time. How could I solve for Y? 4 over 7 equals Y over 8. If you said 7 over 4 equals 8 over Y, that's fine. It's all the same. Okay, so you have 7Y equals 28. Oh, no, it doesn't. 7Y equals 32. So what would Y equal? You don't have to tell me a decimal. What fraction? 32 over 7. Okay, so you know Y is 32 over 7. Okay, how could I figure out what X is? 4 over 7 equals 3 over X plus 3. Then what? Very good. Cross multiply and divide, so you have 21 equals 4 times X plus 3. 21 equals 4X plus 12. Subtract. 9 equals 4X, so what does X equal? 9 over 4. moving right along. The next examples, okay, they don't draw pictures for you, they just have a little word problem, and we're going to decide if they are similar, and if so, what is the scale factor. Okay, so for number 9, the measures of the sides of ABC are 4, 5, and 7. The measures of X, Y, and Z are 16, 20, and 28. Okay, so you want to set up your scale factor proportions. Okay, you're going to put your small with your small, your medium with your medium, your largest with your large. Okay, so if this is small, medium, large, they listed them in order for you, which is so nice. Okay, we have 4 over 16 equals 5 over 20, which equals 7 over 28. And basically what you're checking for is either that they reduce to the same ratio, or that when you cross multiply you get a true statement. Okay, so what are they all reduced to? 1/4. So that's one way to figure out that they are similar. Okay, or if you cross multiplied, okay, you get 80 and 80, so that's true. And then if you cross multiply on this side, you get 140 equals 140, which is also true. So notice that when you cross multiply, you don't get the same values. That's okay. You just need to make sure that it equals left and right equal each other. Okay. I think it's easiest to simplify your fractions, especially when you have a calculator. So even if the numbers were bigger, say, I don't know, 4 and 56, okay, type it in your calculator, hit math frac, see what it reduces to, write that, then do the next one, write that, next one, write that, whatever. Okay, so your scale factor is 1/4, and it would be yes, and what would be the reason? Side, side, side. Yes. Right. You could have 1/4 or 4 because it didn't say which one was the image or pre-image. Any other questions? That was a good one. Was that your question? Okay. Number 10, triangle PQR has sides 3, 5, and 6. STU has sides 2.5, 2, and 3. So small, medium, long. Oops. See, this one they write it in different order, so be careful. Small, medium, long. Okay, so my small is 2/3. I'm going to go backwards this time. 2.5 over 5 and 3 over 6. What is 2.5 over 5 simplify to? 1/2. What is 3/6 simplify to? Okay, so what happens here? They're not all the same, which means they can't be similar. Do we write a similarity statement when things aren't similar? No. So no similarity statement.
Oh my God.
Guys, you're already freaking out, but we've already pretty much done these proofs. You just didn't even know. Okay, first one. Yay! Guys, I promise you're going to be like, I'm so much better at these than I was at the first ones we did. I promise. Okay, statement, reasons. Okay, what's the first statement and reason? Given. Yay, 2 points. Okay, so I'm trying to prove that these triangles are similar, right? Okay, so let's pull apart our triangles as if we were solving a problem. J, K, N. And J, L, M. What do we know in these two triangles already? They share a point, so what do we know about J? J equals J, right? Or J is congruent to J. Who remembers what that's called? Reflexive. See? Ooh, learning new things. Making connections. Those light bulb moments. Okay, what's another set of angles that are congruent? Why are M and N congruent? They're corresponding. Okay, but rather than saying M and N, J and K and JML. So angle JNK is congruent to JML because corresponding angles. What other angles are corresponding? JKN and JLM. But we only need to prove how many angles are congruent? 2. So now what do we know? Angle. So go to your proof statement. It's triangle JKN is similar to triangle JLM, and our reason? AA, similarity, theorem. And voila, you're done.
Oh, I like that.
So a little bit of the old stuff mixed with a couple theorems, and we're done. I can't promise you the next one's going to be as easy, but it's not bad. That one wasn't bad, and you guys didn't believe me.
Yeah. Is there a skills check or is there?
I don't think so.
Yay. Today there is. It says on the calendar.
No proof. Okay, let's get through this. It's the last thing, right? Yeah. Okay, next one. Statements, reasons. Okay, what goes in number 1? Given. So AC is perpendicular to BD, and DE is perpendicular to AB, and that is because it is given. Okay, before we tear apart our triangles, what else do you know? Angle 3 is congruent to angle 4. Why?
Because they're vertical.
Vertical angles. Okay, so we're trying to prove that this guy is congruent to this guy. Okay, so if AC is perpendicular to BD, what do we know happens around here? What kind of angles are produced when you are perpendicular? 90. Okay. And DE is perpendicular to AB, so what's happening over here? Perpendicular. Okay, so now what do we know? Wait. Before we say they're congruent, we have to write what we just put down, which is what?
Oh, the 90 degrees.
So angle 1 is equal to 90 degrees, and angle 2 is equal to 90 degrees. Why? Perpendicular. Definition of perpendicular. So that's the step people are going to forget. Okay, you can't just say and put a right angle and say that they're 90 degrees until you've given a statement and a reason. Okay, now we can say what? Angle 1 is congruent to angle 2 because I heard somebody say it back. Transitive. So remember, it's kind of like substitution, but when it's not across operations, it's just transitive. Okay? If it's across operations, then it would be substitution. Okay, so we know 1 is congruent to 2. We know 3 is congruent to 4. So now what? AA. And voila, we're done.
For step 4, could you justify with definition of right angle?
No, not really, because that's kind of what you did in number 3. Definition of perpendicular creates right angles. And you're done. You have 2 proofs that you just need to be familiar with. Questions over today's lesson? What are my similarity theorems in the order we learned them? Nice. How many are there? 3. Okay, that's all.